Welcome everyone, I'm Brent Testerman with CFM Company. In this video you will learn the advantages of a stay-in-place bypass replacement of an original ABB E-bypass with an upgrade to a new ACH580 drive. Note: the content in this video is for educational purposes only. Warning: working with high voltage electricity is hazardous. Obey the printed warnings and safety instructions published in the IOM manual for the drive. If you ignore them, injury or death or damage to the equipment can occur. If you are not a qualified electrical professional, do not do electrical installation or maintenance work. For customers who have an older ABB drive with an electronic bypass, the original drive hardware has certainly outperformed its intended service life. It is common to find facilities that have ABB drives with 15 years or even 20 years of service still running strong. As time passes, the aging components in the original drive enclosure will eventually wear out. When the equipment does fail, the customer must quickly consider their replacement options. Does the customer need to replace the entire drive and bypass? Does the customer need a bypass? Can any of the good components from the original bypass be reused? For customers who require the redundancy of a bypass, applications such as a pump or a cooling tower, the stay-in-place bypass replacement covered in this video will not work. Even though the original electronic bypass may be functional, the internal bypass components are obsolete and not available. The problem with using the original bypass is that a customer could replace the damaged drive with a new ACH580 drive and then quite possibly a week later have a component of the original electronic bypass fail. This would cause an additional outage. To achieve the redundancy goals required by the system and to avoid a future failure of the original electronic bypass, the customer will need to replace the entire enclosure with a new ACH580 drive and Eclipse bypass. However, there are customers who know that their equipment cannot run across the line at 100% speed in bypass. Typically, this applies to equipment that must maintain a pressure set point, such as a supply fan, a return fan, a building pressure fan, a lab exhaust fan, or a fan used for fire smoke and life safety. For these equipment types, use of bypass will overpressurize the system and could cause serious life safety issues for the building's fire smoke applications. For pressure-dependent applications, bypass is not a usable redundancy option. For customers where the original drive included an electronic bypass and running the motor across the line at 100% speed cannot be used, a stay-in-place replacement should be considered. The customer can upgrade to a new ACH580 drive and reuse key components of the original enclosure. This will help to reduce installation costs and save money. To start, let's begin with a brief history of the ABB electronic bypass. Starting in 1998, ABB introduced the new ACH400 drive and the new electronic bypass option. The electronic bypass offered a standardized product across all the horsepower ranges and input voltage types. After several years of production and feedback from use in the field, ABB updated the bypass control board with a revision known as the Enhanced Electronic Bypass. In 2003, ABB introduced the ACH550 drive and continued to offer the Enhanced Electronic Bypass. For the era, the electronic bypass offered industry-leading standards that are still in use today. Features such as microprocessor-controlled bypass, selectable class 20 or 30 overload curve, underload broken belt trip, single-phase protection, selectable manual or automatic bypass, fireman's bypass override, integrated damper control, multi-voltage power supply, and many other features. In 2007, ABB introduced the Eclipse bypass, offering additional features and options to replace the E-bypass. In 2012, ABB moved the electronic bypass to obsolete status, meaning that parts for the electronic bypass are no longer in production and no longer available. Let's review the power wiring for the electronic bypass for both frame sizes R1 and R2, and frame sizes R3 and R4. Understanding how the electronic bypass is wired will help us later to carefully remove components for the stay-in-place bypass replacement. Starting with frame sizes R1 and R2, the three-phase power is connected to either a main circuit breaker or a main disconnect. The power wires go through a CT board and connect to the line side of the bypass contactor, 2M. If equipped, the drive may have a line reactor. Next, the power wires connect to the bypass power board. For frame sizes R1 and R2, the drive fuses are integrated into the bypass power board. If equipped, the drive may have a drive service disconnect. The power is then connected to the drive input terminals U1, V1, and W1. The drive output terminals U2, V2, and W2 are connected to the line side of the drive contactor, 1M. The output of the bypass contactor, 2M, is wired in parallel to the output of the drive contactor, 1M. The output of the bypass and drive contactors is wired to the motor terminals on the CT board. The customer connects the motor leads to the motor terminals on the CT board. On frame sizes R3 and R4, the three-phase power is connected to either a main circuit breaker or a main disconnect. The power wiring goes to the line side of the bypass contactor, 2M. If equipped, the drive may have a line reactor. Next, the power wires connect to the fuse block. If equipped, the drive may have a drive service disconnect. The power is then connected to the drive input terminals U1, V1, and W1. The drive output terminals U2, V2, and W2 are connected to the line side of the drive contactor, 1M. The output of the bypass contactor, 2M, is wired in parallel to the output of the drive contactor, 1M. The output of the bypass and drive contactors is wired through the two current transducers. Then the output wires land on the motor terminal block. The customer connects the motor leads to the motor terminal block. The advantage of reusing the original bypass enclosure is that the conduit connection for the three-phase line wires, the conduit connection for the three-phase motor wires, and the conduit connection for the building automation controls can stay in place. This makes it possible to complete the retrofit in a few hours with minimal changes to the original hard-piped electrical connections. For our example today, we will be replacing a 25 horsepower ACH580 drive with a new ACH580 drive. The original ACH550 drive is a good unit and the customer will use it as an on-hand spare. The main disconnect, fuse block, fuses, and the motor terminal block will stay in place and be reused. The E-bypass components, including the bypass power board, bypass control board, bypass contactor, drive contactor, and current transducers will be removed. For the R1 and R2 stay-in-place bypass replacement, only the main circuit breaker or main disconnect can be reused. For these frame sizes, the fuse block and the motor terminal block are integrated into the printed circuit boards that will be removed. A new fuse block will need to be installed. Fuses with the original amp rating and fuse type should be used. The original fuses can be reused if they are good. And a new motor terminal block will need to be installed. Before removing the front cover of the drive enclosure, disconnect the power to the drive. Lock out and tag out the circuit disconnect and make sure that reconnection is not possible. Always wait for 5 minutes to let the intermediate circuit capacitors discharge before you continue. Remove the front cover of the drive. Verify that there is no voltage on the line side wires by using a voltmeter. Check the line side voltage, line A to ground, line B to ground, line C to ground. These readings should read near 0 volts AC. Check the line side voltage, phase A to phase B, phase B to phase C, phase C to phase A. These readings should read near 0 volts AC. Once it has been verified that the line side voltage is dead, verify that the meter is working properly. Using a local power outlet, verify that the meter is not dead. The meter reads 122.4 volts AC. This procedure is known as the dead not dead voltage check. The meter measured the line voltage of the VFD power leads as dead. Then the meter was used to measure the outlet voltage to verify that the meter is not dead. Knowing that the line side voltage is truly dead and the meter is not dead, disassembly of the electronic bypass can start. Starting at the main disconnect, the line side power wires are removed. The plastic access shield must be removed. There are two No. 3 Phillips head screws in the lower corners that hold the front disconnect plate to the enclosure. Remove the screw on the lower right by the motor terminal block. Remove the screw on the lower left by the drive input fuse block. The two screws that hold the bottom conduit box to the enclosure may need to be backed out to allow the metal tabs of the front disconnect plate to slide past. Remove the line side power wires from the main disconnect. Carefully remove the front disconnect plate, keeping clear of the control wires that may run in front of the plate. Next, remove the line side wires from the motor terminal block. Keep the three-phase motor leads connected. Remove the two current transducers from the back plate. Remove the line side wires from the fuse block. The three-phase wires that connect to the VFD input terminals will stay connected to the fuse block. Next, the bypass control board will be removed. Keep the control wiring in place. To remove the control board, place both hands inside the plastic frame and apply an outward force. This will release the lower plastic holding tabs. Push the frame upward to release the top holding tabs. Remove the ground wire from the power board connector. Allow the bypass control board frame to dangle. This will allow access to the bypass power board. Next, on the upper right corner of the bypass power board, use a pair of needle nose pliers to remove the plastic retaining pin. Remove the center-mounted Torx mounting screw from the power board. Apply an upward pressure to the bypass power board. It should slide upward. Then remove the bypass power board from the slot pins. Next, remove the three-phase conductors from the VFD output terminals U2, V2, W2, labeled motor. Remove the ground conductor from the ground lug. Remove the three-phase conductors from the VFD input terminals U1, V1, W1, labeled mains. Next, remove both bypass contactor 2M and the drive output contactor 1M from the DIN rail mounted to the backplate. Remove the ground wires connected to the backplate. Use a cell phone camera to take pictures of the control wiring. Both the control wires landed on the drive and the control wires landed on the bypass. Mark, remove, and cap any analog input and output wires from the VFD. These control wires will be reapplied to the new ACH580 drive. For this example, these are the field wires landed on terminals 1 through 9. The remaining bypass wires in the gray jacket should be removed from the drive. This includes the conductors: green, blue, purple, orange, red, white, and black. If there are serial communications wires landed on the original drive, make sure to note the wire color and polarity. Find out the network information for the drive, such as network protocol, BACnet, Johnson N2, Siemens FLN, or Modbus. The EFB station ID, also known as the MAC address. The global address, also known as the instance ID. The EFB baud rate, the EFB parity, and the EFB control profile. All of the components for the bypass can be removed from the drive enclosure. Keep in mind that the control wires are still connected to the bypass control board. With all the bypass components removed, the fuse block, motor terminal block are all that remain. Last of all, remove the original ABB drive. In our example, this is an ACH580 drive. The new ACH580 drive is shown already installed. The installation process is beyond the scope of this video. Installation was performed following the installation instructions found in the IOM that was shipped with the new drive. Starting with the three-phase line-side power wires, terminate the drive input wires to L1, L2, and L3. With the removal of the drive output contactor 1M, new three-phase conductors will need to be cut to length. The new conductors will need to reach between the drive output terminals and the motor terminal block. Land each new conductor on the drive motor terminals T1U, T2V, and T3W. Land the original ground conductor to the drive ground terminal. Cut the new output conductors to length at the motor terminal block. Land each output conductor to the line side of the motor terminal block. Next, install the 3 power wire conductors between the fuse block and the main disconnect. Next, the front disconnect plate is installed with the 3 power wires pulled over the top. Secure the front disconnect plate with the 2 number 3 Phillips screws. Install the screw into the lower right bracket next to the motor terminal block. Install the second number 3 Phillips screw on the lower left bracket next to the fuse block. Not shown. If the screws holding the lower conduit box were loosened to remove the front disconnect plate, tighten them to secure the conduit box. With the front disconnect plate installed and secured, the 3-phase power wires from the fuse block should be pulled over the top of the plate. Connect the 3-phase power wires from the fuse block to the load side of the main disconnect. Next, connect the main ground wire to the ground lug on the front disconnect plate, and connect the main 3-phase line side power wires to the bottom of the disconnect. Install the plastic access shield over the fuse block and motor terminal block. During the bypass removal process, the electronic bypass control board was detached and moved to the side, while the original field control wires remained in place. Correctly identifying the function of the field wiring is dependent on the model of electronic bypass being worked on. The function of the terminals is different for each model. Caution: the field wiring connected to the bypass control board may use 120 volt AC. Use a voltmeter to verify the voltage of each field wire to ground. There are 2 models of bypass control boards. The original electronic bypass control board is identified with a single adjustable dial in the lower left of the control board. The enhanced electronic bypass control board is identified with dual adjustable dials in the lower left of the control board. Starting with the original electronic bypass control board, EBP, the frequency reference is landed on analog input 1 terminal on the drive. On the bypass, terminal 1 is the auto start-stop command. Terminal 2 is the run-enable interlock used for external safety devices wired in series. Terminal 3 forces the bypass to be active. Terminal 10 is the common reference for the bypass digital inputs. Relay 1, terminals 14, 15, and 16 is the drive fault relay. This relay is energized when the drive is energized and when the drive is not in fault. Relay 2, terminals 17, 18, and 19 is the drive run relay. It is wired in parallel with Relay 3, terminals 20, 21, and 22. The bypass run relay. Together, these 2 relays provide the motor run status. Relay 4, terminals 23, 24, and 25 is the bypass fault relay. This relay is energized when the bypass is not in fault and the overload protection is reset. Next is the Enhanced Electronic Bypass Control Board, EEBP. The frequency reference is landed on the analog input 1 terminals on the drive. On the bypass control board, terminal 1 is the auto start-stop command. Terminal 2 is the run enable, typically used for a damper end switch. Terminal 3 is the safety interlock, used for field-installed safety devices wired in series. Terminal 4 activates the fireman's override. This input forces the bypass to run the motor at 100% speed across the line, ignoring all safeties, faults, and user inputs. Fireman's override mode is designed to run to destruction. Terminal 5 activates the bypass override. In this mode, the bypass follows the start-stop, run-enable, safety interlocks to run the motor in bypass. Terminal 15 is the common reference for the bypass digital inputs. Relay 1, terminals 16, 17, and 18 is the bypass fault relay. This relay is energized when the bypass is not in fault and the overload protection is reset. Relay 2, terminals 19, 20, and 21 is the system run relay. This relay is energized when the motor is powered either by the drive or the bypass. Relay 3, terminals 22, 23, and 24 is the system started relay. 3 conditions must exist to energize this relay. A start command must be present, the safety interlock input must be made, no active faults in the system. The system started relay is ideal for damper actuator control. Relay 4, terminals 25, 26, and 27 is the mode override relay. Its function is configured with the dip switch number 2. Off equals mode, on equals override. If relay 4 is configured for mode, dip 2 is off, default. The relay is energized when in bypass and de-energized when in drive. If relay 4 is configured for override, dip 2 is on, the relay is energized when in override and de-energized in all other modes. Relay 5, terminals 28, 29, 30 is the drive fault relay. This relay is energized during normal operation and de-energized when a drive fault has occurred. Relay 6, terminals 31, 32, 33 is the handoff auto relay. This relay is de-energized when the bypass is in hand or off and energized when the bypass is in auto. Not shown in this video, many of the original field control wires were spliced and extended to reach up to the new ACH580 drive terminals. Starting at the top, the frequency reference is connected to the analog input 1, terminals 2 and 3. The start-stop command is connected between the 24 volts DC, terminal 10, and digital input 1, terminal 13. The start interlock 1 is connected between the 24 volts DC, terminal 10, and digital input 4, terminal 16. Continue to land the field controls to the new ACH580 drive per the appropriate functions. For this bypass replacement, the original field controls used a current switch for status on the motor leg. The original current switch is reapplied to one of the motor legs between the output of the drive and the motor terminal block. If a current switch is not being used, the run status wires will be landed on relay 2, terminals 22 and 24. If a fault status is required, use the fault status relay, terminals 25 and 26, the normally closed contacts. The fault status relay closes on a fault or on the loss of power. If there are serial communications being used, land these wires on the embedded field bus terminals, EFB. With all the field wiring complete, use zip ties to contain the field wiring. Apply the drive cover and the bottom enclosure cover. Notice that the opening for the bypass control board has been covered to prevent access. Making certain that all personnel are out of the equipment and that they are at a safe distance away from the drive enclosure, remove the lockout tagout from the main circuit breaker and energize the equipment. Apply power to the drive enclosure and perform the standard startup programming for the new ACH580 drive. Once programming is complete, verify motor rotation. Verify that all field controls, including start-stop, start interlock, frequency reference, and status, are working properly with the building automation system. With the stay-in-place bypass replacement complete, the user can experience a long service life from the new ACH580 drive. Thank you for watching this video. Visit us at cfmcompany.com to learn more about each of the manufacturers that we represent.